All right, section 2.2, we're talking about linear equations in one variable. Okay, so a linear equation is an equation of a straight line written in one variable. So it looks like this right here. Now, the a and the b are going to be numbers, so let's write out, we'll say 5x plus 2 equals 0. That's an example of this right here. Now notice I only have one variable, x. So that's what we're dealing with, equations in one variable. It doesn't have to be x, it could be 5y plus 2 equals 0. But I only have one letter in this equation, so that's one variable. Now notice when we're talking about linear equations, whatever letter that you have or variable that you have is always raised to the power of 1, which most of the time you don't see anything written there. So if you don't see any power, then you can assume that the power is 1. And if the power is 1, then we're talking about a linear equation. Okay, now this line right here says a linear equation in one variable can be written in the form ax plus b equals 0, where a and b are real numbers, kind of like here the 5 and the 2. And it says that a cannot be 0. So say that a was 0. So say that this was 0. Then what happens is this entire term goes away because anything times 0 is 0. And then you're left with two constants. And this actually comes out to a false statement. So if you get rid of that number a, or if you get rid of your variable x, then it's no longer a linear equation. Okay, so that's why a cannot be equal to 0. Now, the solution set will be all the x values that make this equation true. And we're going to look at three types of equations. One will be identity, conditional, and inconsistent, and we'll go through each one of these. So the identity equation. This is true for all variables or all values of that variable. So every single number that you could think of, if you plug that into the equation, then it's going to come out to a true statement. Now if we look at this equation right here, 3x plus or equals to 2x plus x, which means I'll have 3x equals 3x. Now if I subtract 3x from this side and this side, that's how I get the 0 is equal to 0 right here. So notice, number 1, 0 does equal 0, so I have a true statement. But also notice that all my variables are gone, so I have no variables. So when I have these two things together, a true statement plus no variables, that's when you can say that your solution set will be all real numbers or any number that you can think of. So the solution set is all real numbers because any real number substituted for x will make the equation true. So another way of writing all real numbers goes from negative infinity to infinity, or you could write this right here. That means all real numbers. Most of the time we won't see this right here in this class. We'll see negative infinity to infinity. For the conditional equation, the conditional equation is true for only some values of the variable. So where this is true for every single variable, this one is only true for some values. So if we look at this equation, so what you're going to do, this should be a 3 right here. If you take this equation and you subtract 3 from both sides, that's how I get the negative 3 over here, 3x, and subtract 2 from both sides, that's how I get the negative 2 over here. And then you take 5x minus 3x. That gives you 2x. And then negative 6 minus 2, that gives you negative 8. Divide both sides by 2, and that'll give you negative 4. Now before we say, okay, this is my answer, what you always want to do with these is check your answers within the original problem. So everywhere I see an x, I'm going to plug in negative 4. So 5 times negative 4 plus 2 is equal to 3 times negative 4 minus 6. So negative 20 plus 2, negative 12 minus 6. This would be negative 18, and this would be negative 18. Okay, so this came out to a true statement. So that means I know that x equals negative 4 is my answer. Okay, now notice that this is my only answer for this equation right here. So only some of the values, in this case just one value, works for this equation. Okay, so how you would set up your solution set, you would have these brackets right here and include all the numbers that made the equation a true statement. So the only one we got is negative 4. This is a conditional equation. Now an inconsistent equation, this is going to give you a false statement. So if we look at this, now I'm going to move the negative 5 from here to the other side. That's how I'm getting it right here. And we're going to move the negative 15 over to the other side as well. That's how I'm getting it. Should be a negative right here. Negative, oh, sorry, should be a positive 15. That's how I'm getting the positive 15 right here. So I get 5x minus 5x, that gives me the 0. And then 15 minus 20 gives me the negative 5. Now, number 1, we see that we have a false statement because we know that 0 doesn't equal negative 5. And we also have no variables. So all our x values have gone away. So when I have these two things combined together, then I know that I have an inconsistent equation. And for an inconsistent equation, that means that you have absolutely no solution. So your solution set would be a 0 with a slash through it. We call this the null set. But the thing to take away is you don't have any solutions. There's not a single x value that would, if you plug it into this equation right here, that would give you a true statement. It's always going to give you a false statement. Okay, now let's look at this one right here. So first thing I'm going to do is subtract my 7 from both sides. So that's going to be 2x is equal to 12. Divide both sides by 2. So x equals 6. Now before I say, okay, done, there's my answer, I have got to check my solution. So 2 times 6 plus 7 is equal to 19. 2 times 6 is 12 plus 7 equals 19. 19 equals 19. Okay, so because this came out to a true statement, I know that x equals 6 is my final answer. So because only some of the values work for this equation, that means that I have a conditional equation. If we look at this one, I'm going to rewrite it. The first thing I'm going to do is I'm going to take this negative 2 and distribute it to the 3x and to the negative 1. So negative 2 times 3x will give us negative 6x. Negative 2 times negative 1 will give us positive 2. And plus x equals 14 minus x. Okay, and then I'm going to combine my x values. So I have negative 6x plus x, so that will give me negative 5x plus 2 equal to 14 minus x. I'm going to move x over, so I'm going to add x to both sides. So that's going to give me 4x, negative 4x plus 2 equals 14. Subtract that 2 from both sides. Negative 4x is equal to 12. divide by -4. Okay, so x is equal to -3. Okay, so make sure you check. So -2, 3 times -3, minus 1, plus -3 is equal to 14 minus -3. So -2 times 3, this is going to be -4 minus 3 is equal to 14 plus 3. -2 times, we'll go ahead and multiply that out. -12 minus 3 is equal to 17. -2, -12 be a positive 24. Oh, I'm sorry. I messed up right here. I tell you, if you leave off one parentheses, everything's going to explode. All right, so let's try that again. So I had a 3x right here, so I should have a -3 right there. And then I have an x right here, so a -3 right here, and an x right here, so a -3 right there. Okay, -2. So that's a -3 times a 3. So that's a -9 minus 1 minus 3 is equal to 14 plus 3. -2 times -10 minus 3, that's 17. That is a positive 20 minus 3 is equal to 17. 17 equals to 17. Okay, that comes out to a true statement, so that means that I know that x equals -3 is my final answer. Because I only have one answer, that means that this equation here is conditional. Okay, let's look at this one. 15 plus 6x is equal to 1/2 times 32 plus 12x minus 1. Now the first thing I'm going to do here is I'm going to distribute this 1/2 to the 32 and to the 12x. So 15 plus 6x is equal to 32 over 2 plus 12 over 2 minus 1. 15 plus 6x is equal to, okay, 32 divided by 2 is 16, plus 12x divided by 2 is 6x minus 1. 16 minus 1 is 15. And then I'm going to subtract 15 from both sides. So I get 6x is equal to 6x, and then I'll subtract 6x from both sides, and then I get 0 is equal to 0. Now notice two things. Number one, I have a true statement. And then number two, I have no variables left. So when I have these two together, that means that I have an identity equation, which means the solution set is all real numbers, or from -infinity to infinity. Okay, now let's look at this one right here. 6x minus 2, 3 times 2x plus 1 minus 4. First thing I'm going to do is distribute this 3 to the 2x and to the 1. 6x minus 2, 3 times 2x is 6x. 3 times 1 is itself 3, minus 4. Okay, so 6x, and then 3 minus 4 is -1. Okay, so I'm going to add 1 to both sides. So I have 6x. This will be minus 1 is equal to 6x. I'll go ahead and subtract the 6x. So I have -1 is equal to 0. So two things here. I've got a false statement and no variables. So when I have these two together, that means that I have no solution. and this is an inconsistent equation.